look at the degree, and then you go from the degree, you find whatever like term each side of the triangle is.
Okay, yeah.
So hypotenuse would be the longest.
Well, if we think about similar triangles, first of all, which you're all thinking about now, I know. If we think about a similar triangle to this one, let's say it's double the size. Yeah. Happy with that? This is a similar triangle? Yeah. Is this angle the same as this angle?
Yes. Yeah.
Okay. Right. What happens if I only change one of the sides? So let's say I keep this as 3, keep that steady, but bring this one up to 8. Definitely different, yeah. My God, different. Is it going to be bigger, or is this one going to be bigger or smaller? Bigger, definitely, yeah. So if you keep this side locked and you keep making the side across from the angle bigger, the angle gets bigger, yeah? Okay? So someone figured that out, and they named these sides, and they figured out that the ratio is directly related to the angle. The ratio of sides, lengths, is directly related to the angle. So you can make a fraction out of this. So when we did ratios, one is twice as big, but like this is twice as big as this. But the ratio of this side to this side is 4 to 3, or 4 over 3, is it? So the ratio of this is 8 over 3, and this angle is bigger. And if I made this even bigger, let's keep this locked, and made this 20, this angle is starting to get as big as it can go. Yeah? Right. So those ratios have specific names, but in a triangle we also figure out what the side names are to help us figure out those ratios. So in this triangle, there's a very special name to the side opposite the right angle, and you should know, maybe you should know what this is? Hypotenuse, yeah. Oh, hypotenuse. Well, since I actually spelt it.
I thought it was just hypotenuse.
I did not know it had H.
Does it have H? Maybe it doesn't, does it?
I don't think it does.
Definitely doesn't have a H.
I'm pretty sure it doesn't.
Yeah, that's right.
I have not, I probably haven't spelled it in about 3 or 4 years. This is the last time I taught year 10. Hypotenuse. I thought I had a H. Anyway, I'll believe you. I'm not. You like that more?
Yeah.
Hypotenuse, okay. So the angle opposite the right angle is called hypotenuse, yeah. What's the angle or the side across from the angle called? Opposite, yes. It's directly opposite. And this one is adjacent, yeah. Adjacent side, the one alongside it. So I was talking about the ratio. I was looking at, when I was doing those examples, the ratio of which 2 sides? I was always looking at the ratio of opposite compared to adjacent. I'll shorten them down. And I noticed that yeah, as the opposite side got bigger, if the adjacent side stayed locked, the angle got bigger, yeah. And these two compared has tan as our, that's that ratio, the ratio of comparing the opposite side to adjacent side. The ratio of comparing the opposite side to the hypotenuse, if you compare the opposite compared to the hypotenuse, is sine, or sometimes spelled with an E, but usually spelled like this, is the opposite side compared to the hypotenuse. Now let's talk about that one for a second. What range of numbers will this always be between? If I simplify the fraction as much as I can. You can think about our large triangle here. In this one, it would be the opposite side is 8, and the hypotenuse is 10. So that would be 8/10, or 8 over 10, or 0.8. What is the largest possible value that this could be?
1.
Could it be 1? What's a very important thing we're talking about in this style of triangle we're dealing with? It's what type of triangle?
Right angle, yeah.
It's a right angle triangle, okay? So that's 90 degrees, yeah? If sine is 1, what would that mean?
It's not.
It's also at 90 degrees, is it? Well, that means that this side would also be 10, but that would make this angle non-existent, yeah, or well, it would be 90 degrees, but it wouldn't work in this triangle. Yeah. No, the biggest value we can get in this is 0.999 recurring. We could get 1, but it wouldn't be in a triangle. Yeah. You could then you have to start thinking about angles in general, not just in a right angle triangle, as it goes around in a circle. After 90 degrees, it keeps going, it doesn't stop. Angles form a circle and continue. That's called circular motion. Anyway, we won't overly confuse the issue with that. The main thing is that in exam, you may notice that you get a ratio such as, let's make it a bit, 12/7 for this. And would that make sense? Nope. That would suggest that the opposite side was 12 in length, and the hypotenuse was 7 in length, and that forms some sort of right angle triangle. Hypotenuse will always be the longest side because it's always opposite the biggest angle. And the biggest angle in a right angle triangle is 90 degrees. So there's two that the ratio we haven't looked at. Which two have we left out? The adjacent compared to the hypotenuse is cosine. Now, some of you may think, why don't they compare it the other way around? Hypotenuse compared to adjacent. Why don't they compare it this way around? They being the imaginary mathematicians that were... they do, actually. And this is what you will deal with in IB. It's called sec. This one, I know, it's actually CSC for short. You may see this. This is the opposite one. This one won't come up. This is just purely for interest's sake. Cot is this one upside down. So that you can compare them upside down and you will get the same, but we don't deal with this until the IB. Cosec. Cosecant. This stands for secant, and this stands for cosecant. It shorts down. So.
Is that the -1?
The inverse? No. It generally isn't. It's not on these calculators. Only on these calculators. Yeah. So it'll be on your good calculator. This is not what we look at. We only look at the ratios when they're this way around. Fantastic. What's fantastic about that is that if we have the lengths of sides of a triangle, we can now get the angle in a triangle. So for instance, if I know that sine theta is 1 divided by 2, or the ratio of the opposite sides of the hypotenuse is 1 to 2, how do I find what the angle is? Type it in. How do I type it in on the calculator? Yeah, so how do I turn this? I want to know what the angle is. The angle, or this symbol, theta, is what? When sine theta is 1/2. Well, I could have an estimation. If that is, the hypotenuse is 2 in length, and this is 1. I tried to draw that. So something like that. That's what that looks like. Hypotenuse is 2 in length. Opposite side is 1 in length. We have this angle over here. I could get the other angle of this using Pythagoras. What would it be? The other side of this using Pythagoras. 4 minus 1 rooted, so root 3. Wouldn't it be? No? 2 squared minus 1 squared. Yeah. But what's the angle? Here was that video. Sorry. How do I turn it around? How do I turn? There is a special button on your calculator.
Sine minus 1.
Yes. If I want to go inverted, I go sine minus 1. So try and find that button on your calculator. Type in sine minus 1, 1 divided by 2, and you should get an angle in degrees. 30, yeah. We'll come to that. We'll come to picking which one you use.
Based on which one we actually have.
But like, let's say, because when we had it in physics, I used process of elimination, which one actually was a number. Like, let's say you didn't have the opposite, then you would have to use the adjacent.
Yep.
You'd have to.
Okay. So if we have the ratio and we want to find the angle, we use this button on your calculator. If it's sine, cosine minus 1, or tan minus 1.
What is that minus 1 actually called?
It's inverse. It's sine inverse, or you may also see inverse sine is what you would say. Some people say arc sine, which is another thing that you will see more of when you get to IB. Arc sine or inverse sine,
That just means that.
the other way around. Yeah. Okay, so let's look at an example of what you're going to see in a second. Let's say we are given an angle, 60 degrees. We have a side, 3, and we want to just find what x is over here. Yeah, Eloise.
Oh, what? Oh, so it's, oh, would it be
Well, what's the...
63?
Oh, you're going too fast. Yeah, you could be. Well, the first thing I would do is, what two sides do I have? I have the opposite over here, and I have the adjacent over here. Not the hypotenuse, because this one's opposite triangle. We don't have that. So then I look at this. Which one deals with opposite and adjacent? The first one has opposite and adjacent. So I can write this sentence. Tan of the angle I was talking about is the opposite divided by the adjacent.
Wait, don't you have to put, like, and when you put that in an equation, do you have to put 16 brackets?
No. So your calculator will give you a value for this. Before you type it in, what do we expect the value to be for tan 60? No idea? What do you expect the value to be for tan 45? No cheating.
10, 61 point. No,
Let's go back. What would 45 mean? 45 degree angle, that's 45 degrees, 45 degrees. What would these two sides have to be? Opposite and the adjacent would have to be the same, yeah? They would have. So what do you expect the value for tan 45 to be? If opposite and adjacent are the same, what's the ratio? Always 1. Yes, always 1. Because if this one's 3, this one's 3. If this one was 6.7, lol, this one's 6.7. So if it's 45 degrees, these two would be the same. So tan 45 is 1. Now, if the opposite side is, well, if tan 60, which is going to be bigger, the opposite or the adjacent, do you think? For 60. So this is 45. Which way is it going to go?
So the opposite.
Opposite should be bigger. So you should get more than what?
like 1.7, 1.1.
Let's see. Press tan 60. What we get? We got 1.73?
Yeah.
Could be 1.73. Okay. So tan 60 on my calculator gives me a decimal. That decimal is the ratio of the opposite side to the adjacent. It's written as a decimal, but it's really a fraction. It's in the ratio of, well, 173 to 100 would be it as a ratio, but you'd never write it like that. But do remember that it is a ratio of two sides. It's a division, a ratio of two sides. And that is equal to 3 divided by x. Now this tests our simple algebra skills. How would I finish this?
3 divided by 10.
Yeah, so you could do a rearrange or cross multiply here. X is 3 divided by 1.73. You could have done that at the start. And that will give me my side, which is it more or less than 3? Could have predicted it was less than 3 once it passes 45 degrees, but yeah. I don't know what it is. What is it?
1.73.
How did that work?
If you do 3 divided by 1.73, 1.73.
3 divided by... It's almost like it's the square root of 3.
Yeah, it's a square root.
Huh.
1.7 squared.
So when you're doing your known angles in physics, did you ever see root 3 over 3 at any stage? Or you see 1 over root 3 at any stage?
Yes.
Now these came from these angles, 45 and I had 30 up earlier, are the ones you know. That's why I drew them in. But we'll come back to the known ones in a minute. We want to problem solve first. Sine, cos, and tan off by heart? Yeah, you need to know it, yeah.
Do we need to know all of this?
No, this is just
For interest.
purely for interest's sake. All right, let's put the angle up here. Timon, Jasper, what's going on? Okay, let's do one more before I set you on your way. Let's put x here and 7 here. And let's give this an awkward angle, 43 degrees. Now I pick what my strategy is. Which two do I have? All right, I have, yes. This is the opposite the angle. This is hypotenuse, opposite the right angle. So which one is opposite hypotenuse? Sine. So sine 43 is x over 7.
Sine 43 times 7.
So what do we expect this to be before we type it into a calculator?
Okay.
Without typing into calculator, what do you expect sine?
Lower than 1.
7 times.
Great start. Definitely lower than 1. It has to be lower than 1.
0.91. Is that close?
43 degrees?
0.86.
It's probably 86 is a known one, yeah. That's good thinking.
0.86.
All right, someone type it in. What's sine 43? What's sine 43?
4.8.
0.68, yeah.
I was the opposite.
Yeah. I multiply it then by 7 to finish. So multiply up 7 times 0.68 gives me my x to finish. 4.77?
I don't understand how you're supposed to
Yeah.
How do you know that it's going to be 0.6?
I don't.
Like, you just.
Oh, you can start to guess because you're thinking about ratios and
But it's such an awkward guess. It's like,
oh, you wouldn't guess, but you were right in thinking right. It's less than 1.
it's lower than 1 because it's lower than 45.
Yeah, and then yeah. When you start to know known ratios, like sine 30 is one I know, and we'll explain why we know these later on, is 0.5. And I know it's between 0.5 and 1,
It's 0.5 because it's half.
but it's closer to 40 than 40 is closer to 30 than it is to 90. So
Because it's not like, it doesn't work, because like sine 43, which is extremely close to 45,
yes.
it goes so much lower than 1. Because it's 0.68.
Yeah, but sine 45 wasn't 1. Sine 90 was 1.
Oh, right.
Tan 45 was 1. And that's where you got mixed up. Tan 45 is 1 because tan is the looking at the opposite and adjacent.
Jason, right?
Yeah.
It's got the different side.
Yes. Okay, let's do. Yeah, it's too riveting for you. Let's do a Kahoot and see how we get on with this. Change it up. Hi. Yeah.
Mr. Collins, when's the IXL due next week?
Yeah, end of May. Okay, so while you're logging into that, cat. So while you're remembering that, some people are doing that. Some people like to remember, Timon, thank you. Some people like to remember these ratios with this acronym, SOCA, TOA. or cilial carry. Oh, so there's something. So this is sine is opposite over hypotenuse. This is cosine is adjacent over hypotenuse. This is tan opposite over adjacent.
Is this bit?
Yeah.
Okay, that means my own
Okay, just your normal name, or I'll kick you out. Thanks. I'll need to know who it is. Yeah.